Welcome to The Explainer. Today, we are diving deep into the very fabric of reality itself. We're talking about matter. The actual stuff that makes up everything you can see, everything you can touch, and even the air you're breathing right now. I mean, really think about it for a second. That chair you're sitting on, the screen you're looking at, your own body. What is it all actually made of when you get right down to the most fundamental level possible? Well, the answer, as we're about to see, is both surprisingly simple and way, way stranger than you might imagine. It's a journey that's going to start with what we all think we know, and it's going to end right at the very edge of our current understanding. So let's get into it. All right, so to really get a handle on matter, we have to start with the basics, right? The classic definition that you probably heard a long time ago in a science class somewhere. We have to start there before we can really start peeling back the layers. Here it is. If it has mass and it takes up space, boom, it's matter. Seems simple enough, right? But that first part, has mass, that's where a really common mix-up happens, and it's a super important one to clear up. So let's talk about mass versus weight, because they are not the same thing. Mass is the amount of actual stuff inside an object. It never changes no matter where you are in the universe. Your mass here on Earth is the exact same as your mass on the moon. But your weight? That's just the force of gravity pulling on your mass. And since the moon's gravity is way weaker, you'd weigh a lot less there, even though you are still made of the exact same amount of stuff. Okay, now that we've got our feet on the ground, let's zoom in. And I mean way, way in. We've defined matter on our scale, but what is it made of at the absolute smallest level you can imagine?
For centuries, the idea was that the smallest possible thing was the atom. In fact, the word atom comes from the Greek word atomos, which literally means uncuttable. The thinking was that it was a tiny, solid, indivisible little ball. But a really clever experiment was about to completely blow that idea out of the water.
So picture this. A scientist named Ernest Rutherford is shooting these tiny particles at a super thin sheet of gold foil. The old model of the atom, called the plum pudding model, suggested the atom was just a soft blob. So he expected all his particles to just zip right through. But that's not what happened. Some of them bounced straight back. Rutherford later said it was as incredible as if you fired a cannonball at a piece of tissue paper and it came back and hit you.
So what did this mean? It could only mean one thing. The atom wasn't a solid ball at all. It was almost entirely empty space. All of its mass was packed into this incredibly tiny, dense, positively charged point right in the middle, which we now call the nucleus. To give you some scale, if the nucleus was a marble in the middle of a football stadium, the electrons would be like little specks of dust flying around in the nosebleed seats. That's how empty an atom is.
And inside this wild structure, we find our three main characters. You've got the protons and the neutrons packed super tightly together to make up that dense nucleus. And then you have the electrons. They're not orbiting like little planets, it's weirder than that. They exist in this fuzzy cloud of probability around the nucleus, and the edge of that cloud is what gives the atom its size.
And it's not a static picture, The brilliant physicist Richard Feynman put it perfectly. He said all these little particles are in perpetual motion, constantly attracting and repelling each other. It's this nonstop dance of forces that actually creates the stable world that we see and feel.
Okay, so we've seen what matter is made of at the tiniest scales. Now, let's zoom back out and look at how all these little buzzing atoms get together and arrange themselves into the forms we see every single day. And really, it all comes down to one thing: energy. When you add energy, usually as heat, you make those particles move faster and spread out. You take energy away, and they slow down and bunch together. That one simple rule is what gives us all the different states of matter. So we've got the big three that we all know: solid, liquid, and gas. But there's a fourth one, plasma, that turns out to be the real superstar of the universe. Let's do a quick run-through. First up, solids. In a solid, all the particles are locked into place in a nice, rigid structure. They don't have enough energy to go anywhere, so they just kind of sit there and vibrate. That's why a solid holds its shape. Now, add a little heat, and that solid melts into a liquid. The particles get just enough energy to break free from their rigid positions. Now they can slide and flow past each other, which is why a liquid takes the shape of whatever container you pour it into. Okay, now crank up the energy even more, and you get a gas. The particles get a huge energy boost, and they break away from each other completely. They just fly around like crazy, bouncing off everything, and they'll expand to fill any space you give them. But what if you keep adding energy? Well, if you get things hot enough,
The atoms themselves start to fall apart. Electrons get ripped away from their nuclei, and you're left with this superheated, electrically charged soup of particles. That is plasma. And get this, while it's kind of rare here on Earth, it's what stars are made of. In fact, more than 99% of all the visible matter in the entire universe is in the plasma state.
So just to nail this down for the first three, a solid has a definite shape and volume. A liquid has a definite volume, but its shape changes. And a gas, it has neither a fixed shape nor a fixed volume. It just goes everywhere. And now for the final, truly mind-bending zoom out. We've defined matter, we've looked inside the atom, and we've seen how it behaves in different states. It feels like we have a pretty good handle on things, doesn't it? Well, it turns out the universe has been hiding a massive secret from us.
Take a look at this chart. This is what we think the entire universe is made of. And do you see that tiny little sliver? That 5%? That's what we call ordinary matter. That is everything we just talked about. Every star, every galaxy, every planet, every single atom in your body. It's all in that tiny 5%.
I mean, let that sink in for a second. That means a staggering 95% of our universe is made of stuff that we can't see, we can't touch, and we honestly don't really understand yet.
And these two mysteries, dark matter and dark energy, are locked in this epic cosmic tug-of-war. Dark matter seems to be the invisible gravitational glue that holds galaxies together. Without it, they'd just fly apart. And dark energy is even weirder. It seems to be some kind of repulsive force that's actually making the expansion of the universe speed up, pushing everything away for everything else, faster and faster. So, we started this whole journey with a really simple definition of matter as just the stuff around us. But we end here, staring into the abyss, with the wild realization that all the stuff we know and understand is just the tip of a vast, dark, cosmic iceberg. It's a pretty powerful and humbling thought, isn't it? It just goes to show you that the biggest discoveries aren't in what we already know, but in figuring out all the things we have yet to explain.